So this instrument is called a YSI, or it can also be called a multiparameter sonde. Sonde just means like a meter. So the way it works is if you open this protective cap, you can install different types of sensors into the ports. So in this instrument, we have dissolved oxygen sensor. We have a pH sensor, and then this is a temperature sensor, and there's a salinity sensor inside there. So there's multiple different ports, which means you can install different types of sensors. So you could also, for example, install like a nutrient sensor, a nitrate sensor, a phosphate sensor, or a turbidity sensor. First, we have to turn it on with this green button here, and then a screen pops up. So we have a long cord here. So if we were using this in the ocean, we could drop the sensor down to whatever depth we wanted. But since it's really shallow here, we're gonna lay it on its side because we don't want to get a lot of sediment clogging up the sensors. Okay, so it's mostly that we want to get the sensor submerged enough that the water touches the sensors. And then you can see on the screen here, and then we have dissolved oxygen in percent and in milligrams per liter. So it's reading at about 27% dissolved oxygen, which is actually pretty low. And that makes sense because the water is not really moving at all, and it's low. Then we have salinity in parts per thousand, and that's reading really low at about 0.1 parts per thousand. And that makes sense because freshwater has a salinity of 0. And we have pH, which is about 7.2, and that's pretty typical. Okay, this is called a turbidimeter. So it measures turbidity, which is the dirtiness or the cloudiness of the water, and that's really dependent on how much sediment is floating around in the water or organic matter. So if the water is flowing really fast, then all of that sediment is going to be kicked up, and the turbidity will increase. But you can see that the water is not really moving at all. So we're going to expect a low turbidity. So first we collect the sample in this little vial here, and we're going to fill it up to the white line. And then we're going to wipe it off with some Kim wipes. So we don't want there to be any smudges on the glass vial. The way that the turbidimeter works is it shines light through the sample. So if there's any smudges, then the light will bounce off of the sample, so you won't get like an accurate reading. So if more light shines through the sample, that means the water is really clear, the turbidity is low. If the light cannot shine through the water, then the turbidity is high. So to turn on the instrument, we just press the power button, and then we insert the vial with the little triangle facing towards you. And then we want to keep the turbidimeter kind of flat. Then we press read. So you can see that the turbidity is 1.47. So that's pretty low. We can get really high turbidities like 40, 50 if the water is really turbid and dirty. And then we just empty out the water. That's it.
So he leo mahalo kia ia o ko pakahia pau no ka hui ana no ka ho'ona nea pu ana me mako no ka ho'oka ike no ka ho'olohe ana I ka ike Hawaii o kia makumu. Mahalo nui for all of you tuning in with us throughout these past days and really, engaging in the ike that has been shared from all these wonderful mentor and kumu of Maui, of Hawaii. He leo mahalo keia again, mahalo to Ka'ehu, again mahalo to all the people who shared and engaged with us in our keiki and our community. And again, this is encouragement to all you folks to find that space in your own community to learn, to engage, to share, to create relationships with Aina and with people and learn more and share more in the culture, in the Aina. And I'm so happy to be able to share with you folks today. and throughout these past days. So mahalo piha ia o ko pakahi a pau. O wau no o ka hakuriti kamara. Ma ka ehu a hui ho, launa pu ho kako i ke kahila. A hui ho.